Okay, see Lindelof videos, making integration easier. Making integration easier. It's kind of a weird thing. For me, this would be very hard to integrate in its present form. However, if I rewrote this, and that's what this R is for, rewriting, if you rewrite, if you see something, you're like, oh my gosh, what am I going to do with this piece of integration? Start asking yourself, can it be rewritten into some simpler form? And that's what I'm going to do. So I'm just going to start by doing my rewrite, and I'm going to say that this is equivalent to, this 2 right here can be pulled out, so I'm going to pull this 2 out as a constant multiple. And then, so would that leave us with 1 over square root x? Well, 1 over square root x is the same as x to the negative 1/2 power, isn't it? dx. This, for me, is just a lot easier to integrate. And from here, remember how to do this integration. We're going to get 2 times, remember we're going to add 1 to this, right? I'm using x to the n. So to integrate x to the n, you get x to the n plus 1 over n plus 1. So that's exactly what I'm doing here. When I add 1 to this, I get x to the 1/2. So I get x to the 1/2 here over 1/2, right? Plus c. Remember, we have our constant of integration here. Plus c. This is a complex fraction, so this comes up as 2. So 2 times 2 is 4. 4x to the 1/2 plus c. This c portion here, this constant of integration, is something I forget a lot, and your professors are not going to tolerate that very well, so you might want to keep that in mind, you guys. All right? So let's go to another example. So here's another example, and in this example, this is, excuse me, this would be a very hard piece of integration for me. So what I'm going to do is, from my rewrite, is I'm going to go ahead and expand this. So as I expand this, I'm going to say that this is equivalent to, and it looks like it's getting messy, but it's going to be fine, I promise. It gives you t to the 4th plus 2t squared, right? 2t squared plus 1, doesn't it? I think so, yeah. dt, right? From here, I know you're like, oh my god, how did that make it any better? This looks worse than the first thing. Actually, it doesn't, because we can use the sum and difference formula of integration, and we can integrate this thing by pieces and say, I want the indefinite integral of t to the 4th dt plus 2. This is a constant multiple, t squared dt plus the indefinite integral of dt. Right? So this actually is not bad. And from here we can just integrate using the rules that we already know. So it's going to do this piece by piece and get t to the 5th over 5 plus, what do we get here? Yep, 2/3 t to the 3rd plus the indefinite integral of this is just t plus c, and there's our answer. So just by rewriting, we get it into a form that we can manage more easily. I know it does look a little bit messier at first, but I'm promising you, it's a great way to make your integration much easier. Get a case like this, and people actually just freak out. This is actually not bad at all. I'm just going to break this into its pieces, and if you would just look at this like this and say, okay, this is this thing here over this thing here, isn't it? And all I'm going to do is I'm going to break it out into those 2 pieces and simplify just using simple algebra. So, excuse me, here's my algebra. That x to the 3rd over x squared is just x, isn't it? Plus, and then I have 3 over x squared, which is the same as 3 times the indefinite integral of x to the negative 2, right? Oh, I need to put dx here, dx here. You got to watch me on this stuff. I'm really sorry. I get in such a hurry to get ahead. If you do this on the on the AP exam and you leave out your dx's, they're going to nick your points. So let's be careful. So when I go ahead and integrate this, just going to go ahead and integrate. I'm going to get 1/2 oh, this is not true, because look, sorry, I got a little bit turned around. X cubed over x squared is just x, isn't it? So if somebody caught that, good job. So here it would be this x squared, right? Plus, actually it turns out to be minus 3. Oh, actually, it's 3 over x, isn't it? 3 over x plus c. So there's my integration of that. I'm not trying to push the integration part as much as I'm trying to point out the fact that if you do rewrites, if you reassess what these things look like, it becomes much easier to do. So I hope this was helpful in some way. If you have any questions or comments, let me know. If you haven't already subscribed, please do. Thanks.